Hello, my name is Julian Pelizeus. I'm a part of the LXD team, and today we'll take a look at MicroCloud's first LTS release and also dive into a few of the features that have been added over the last year. To begin with, there's now the option to create a so-called single-node MicroCloud. Compared to before, there was always a requirement that you need at least 3 systems to create a MicroCloud. With this, you can now essentially start small and grow your cloud to a certain size at a later point in time. But this is especially helpful if you're new to MicroCloud and if you just want to try it out on your local system. Now, let's have a look how to create such a single node MicroCloud. Over here in my terminal, I'm connected to one of my systems that we will now use to create a single node MicroCloud. On the system, the required snaps are already installed, so I can just do snap list, which will show LXD, MicroCloud, MicroCloud, and MicroOven already installed. But you can get the same if you just run snap install, LXD, MicroCloud, MicroCloud, and MicroOven. And this should effectively give you the same, as you can see here on my system. As I also want to show some more features that MicroCloud offers when it comes to the configuration of networking in Ceph. The system has 2 additional network interfaces. So one ENP5, which just gives my system connectivity to the outside world, and then 2 additional interfaces that we will use then for MicroOven and MicroCloud. Now, if you want to deploy a minimal single node MicroCloud, you will only need to have 1 additional network interface. So to get it started, we can type MicroCloud init. And now we are asked if we want to form a single node or a multi-node MicroCloud. In this case, it's single node, so we say no. And here we can select an address for MicroCloud's internal network. In this case, we select the first one. You can select whatever address is available on your system. You might have a dedicated network, or just select the address of the system itself. Now we can set up local storage, so we say yes. And here MicroCloud displays us a list of disks available on this system that are consumable by MicroCloud. As we also want to configure distributed storage at the later step, we just select 1 disk. And here we also select to please wipe this disk, but this step is optional. Now we can set up distributed storage, so we say yes. And now on this system, only 1 disk is left, and this one we will select now. And here we also say yes to wipe the disk. Now, MicroCloud is aware that the current setup is against our recommended settings to achieve fault tolerance, because you need at least 3 disks on 3 different systems for Ceph in order to ensure fault tolerance. But as this is a single node MicroCloud, we basically can't fulfill this requirement. So therefore, we don't change the disk selection and say no. Now we're getting asked if we also want to encrypt the disks selected for distributed storage. So we say yes. And we also ask if beside the remote storage pool that we will be creating, if we also want to have one that leverages CephFS. So we also say yes. This is now also a new feature of MicroCloud. It allows us to configure Ceph's internal, so cluster traffic, and the public traffic. In this case, by default, it always picks the network out of which we've selected an address for MicroCloud's internal traffic in one of the steps before. But in this case, we want to use a dedicated network that we have available on the system to configure or to be used by Ceph. So here we will now put in the right address, which in my case is 10.1.123.0/24. and MicroCloud will check if this network is present on your local system. Then we press enter. Now MicroCloud detected that this network is configured on ENP6. And in the next step, we are asked if we also want to configure a specific network for SaaS public traffic. In this case, by default, it picks the one we've selected for the internal traffic, and we will stick to this. So we have both internal and public traffic bundled on the same network, which is dedicated for SAF. So we just press enter. Now the MicroSAF configuration is done, and we head over to MicroOven. So now we are asked if we want to configure distributed networking. We say yes. And now MicroCloud filters all of the network interfaces on the local system that are usable by MicroOven to be used as an uplink interface. In this case, there's only one left on my system, so I'll select this one. And as MicroCloud isn't aware of the network configuration of this uplink network, as no address is configured on this network, we now need to provide its IPv4 gateway, which in my case is 10.2.123.1/24. And as addresses out of this network will be picked later on to be used for the virtual networks, or as router IP for the virtual networks, we need to provide a range. So we say this range should start at 10.2.123.100, and the range should end at 10.2.123.120. Of course, this always depends on your network configuration and can be different than what I've said here. Of course, also IPv6 is supported, so we can also provide the IPv6 gateway address of this network, which in my case is FD42 2 1234 or 1/64. When it comes to DNS addresses, MicroCloud by default picks the IPv4s and IPv6's gateway. But if you have other DNS servers, now it's the time to put them in, but we will just go with the default. Now we would also be able to configure a dedicated network for the Oven underlay traffic, which is basically the traffic sent within the overlay networks, so between instances. But in this case, we will say no, because we don't have any more network interfaces available on those systems. Now the questionnaire is done, and MicroCloud starts to bootstrap our single node MicroCloud cluster, which means it will create a single node LexD, MicroSAF, MicroOven, and MicroCloud cluster. And after those are formed, it will continue with the configuration of the local and remote storage pools, as well as the first default of a network. And if this is done, our single node MicroCloud is ready and can now be used. So let's have a look what MicroCloud has just set up. First, we can run MicroCloud cluster list. And as expected, this shows us a single entry for a single node MicroCloud. And the same output we now get from Lexi cluster list, just one node. And the same we see when we do MicroSAF cluster list, and also when we do MicroOven cluster list. Now, before we launch an instance, let's also have a look at the profile, because by default LexD has this default profile, and this is configured by MicroCloud. So let's have a look. This is configured by MicroCloud to contain two devices. One is a network device out of default of a network, and the other one is the root disk for the instance, which is sitting on top of the remote storage pool, so managed by Ceph. And for a later example, I will now configure an additional config setting, which will help us at a later point in time to live migrate instances that are already configured on the cluster. For the single node MicroCloud, we don't yet need this, but I will set it now and we will come back to it later. So we can use Lexi profile, set default migration stateful true. There we go. Now let's launch an instance. So we can do Lexi launch. We select the latest noble image. We call the instance we want. We say it should be a virtual machine. And now we can press enter. As the image isn't yet available in this LXD cluster, LXD first has to download it from the image server. And after the image is downloaded, it will then be unpacked onto the remote storage. And from there, we can then create the instance's root volume so that LXD can then launch the instance. So it's now downloaded. In the next step, it will get unpacked. This is running all in virtualized machines, so you should see some better performance if you run it on actual bare metal hardware. Now the image got unpacked. And in the next step, LXD will start it. So we can confirm this by running lexi-list. And now we see virtual machine v1 is running on Micro 01, which is expected because this is the only cluster member that we currently have in the single node MicroCloud. And with this, we're basically ready and set. And we might also face problems now when it comes to failures, right? Because as this is the only node in our cluster, in case MicroOven, MicroSev, or LXD fails, we'll basically observe downtimes of our virtual machine, right? So in order to prevent this, we will now grow the cluster and to 3 nodes, so that we can then leverage features which are only available if we are in a clustered environment. In order to do this, I'll switch to another screen. And here at the top, there's again the terminal connected to Micro 01, so we can do MicroCloud cluster list, which gives us this single entry. And now there are 2 more terminals connected to 2 additional machines that we now want to join to our single node MicroCloud. And in order to do this, on one of the nodes, which are already part of the cluster, in this case only Micro 01, we need to run MicroCloud add. And this is now different to before, because it will now provide us a dice-generated passphrase. And we can now use this passphrase to go to each of the other machines, type in this passphrase, so that we can securely join a cluster and to establish the trust between a new joiner and the existing cluster. So in order to do so, we just head over to one of the new systems and type MicroCloud join as we were instructed. And again, now we have to select an address for MicroCloud to use for its internal traffic. So we just again use the first one. And now we already need to type in the passphrase, which you can see in the first terminal. There we go. We typed in the right passphrase. And now you see the Micro 02 already popped up on Micro 01. And also, we haven't provided the address of Micro 01. And they've discovered each other automatically on the network using multicast. But let's say multicast isn't available on your local network, and you want to join an existing or in a specific cluster using unicast. So you can also do this by running MicroCloud join on the third node. Then you can provide the flag initiator address. and then just provide the address of the system that you want to join, which in this case is 10.8.112.164. So we can now press enter. Again, for this node, we have to select an address that will be used for internal MicroCloud traffic. Now we can type in the same passphrase again. And if we've typed in the right passphrase, we should see the system popping up at the top, which it did. And this shows how you can both use multicast and unicast depending on your use case or depending on your environment. So we head back to the first system, and we can now also consult the fingerprints to again confirm that those are the right systems that now want to join. And now we select those two systems and press enter. As you can now see, Micro01 has now reached out to the other servers to tell them they have successfully established trust, and now it gathered some additional system information. So Micro01 reached out to Micro02 and Micro03 to receive their disk and network setups, which will now be fed into the questionnaire we will now go through. Again, on Micro02 and 3, we will set up local storage. So out of Micro02 and Micro03, we will select each one disk to be used for local storage. And we will again wipe the disks. And also we want to again configure distributed storage, which will just deploy additional OSDs in Ceph, which will then be used in the overall cluster that we will extend. So we say yes, and select the two remaining disks on the Micro02 and 3 for distributed storage. And again, we will also wipe those. Again, we want to encrypt the disks for distributed storage. And here you can see, based on the configuration we did before for Ceph's public and cluster traffic, MicroCloud has detected now that this network is also available on the two new nodes, and so it has also now configured this dedicated network on Micro02 and Micro03, so that the Ceph public and cluster traffic is also going over this network on those nodes. Now, again, back to distributed networking. Again, we want to configure this too on the two new nodes. And again, the interfaces are filtered, so we select those two. And now we are again asked if we want to configure a dedicated underlay network. As we haven't configured this for Micro01 due to the lack of interfaces, we also now won't do it for the two new nodes because they also don't have this extra networking interface. So we say no. Now the questionnaire is complete, and it's almost the same process as before, with the difference that instead of forming new clusters, MicroCloud will now join Micro02 and Micro03 into the existing cluster. As the trust was already established before, during the input of the password, this secure channel is now used to transmit a join token from Micro01 to the new nodes, and those new nodes will use this join token to join into the existing cluster. Micro03 has already done so. Micro02 will now follow, and it needs to join the MicroCloud cluster, the LXD cluster, the MicroCeph, and the MicroOven clusters. And as soon as all of those clusters are joined by the new members, this will be confirmed by Micro01 in the first terminal. And on the other two terminals, you already see that they've successfully joined the MicroCloud, and that Micro01 will now take care of configuring the remaining steps required to join the MicroCloud. As you can see, Micro02 has now also joined the cluster, and now again, the cluster-wide devices, so storage and networking is going to be set up on the two new members, which is now complete and our MicroCloud is now ready. So let's first type MicroCloud cluster list, which should now give us 3 entries for a 3-node MicroCloud. And the same, of course, we will see when we now do lexc cluster list and microceph cluster list and microopen cluster list. Now, as you might see, this process of going through all the cluster list commands is a bit tedious. So another feature that we've added to MicroCloud is the status command. For this, we head back to the original terminal. And here we can now type MicroCloud status, which gives us a nice overview across all the different services that make up MicroCloud. In the first line, we see the overall status of our cloud is healthy. And then in the table below, we see an entry for each of the members in our MicroCloud. We see its address, we see how many OSDs are configured on this exact system, and we see the respective MicroCloud and MicroOven units which are currently present on those systems. And the last column then shows us the overall status of this node. Now, of course, green is good, but what will happen in case one of the machines goes down? So let's see this in action. Let's go back here, maybe to Micro 03 and stop the MicroCloud daemon. Well, let's head back and run the same command again. And now we see our MicroCloud is in error status, right? Because MicroCloud isn't available anymore on Micro 03, so it's basically unreachable. And it also now can't query anymore for additional information like MicroCloud and MicroOven, because MicroCloud is really the communication path across the cluster. When we look at the messages, we see there's a potential for data loss because there are no more 3 disks or OSDs available across 3 different systems. And also MicroCloud doesn't seem to be available on Micro 03. So let's quickly restore the status again. And again, start MicroCloud on Micro 03. Now when we go back and run the same command again, we should see our cluster is again in a healthy state. And we're ready to perform some workload-related actions. So remember, after we deployed the single-node MicroCloud, we've launched an instance. This instance is, of course, still running on Micro 01. So the growing of the cluster hasn't affected existing workload. And but as we are now, or as we now have the possibility to move this instance around, we can do so. And remember, at the beginning, we set a configuration setting on the profile, which will allow us to live migrate this instance now. So what we can do is we can do lexc move v1, and we just supply as a target one of the new nodes that we've just joined to the MicroCloud. For example, Micro 03, the one that we've just stopped and restarted. Let's press enter. And now lexd will live migrate this virtual machine from Micro 01 to Micro 03, which is now done. So we can do again a lexc list to confirm this operation. And we can now see in the last column that v1 is now sitting on Micro 03. But let's also quickly enter the virtual machine and view its uptime. And here we can see the machine is running since 12 minutes, which was back then when we've initially launched the instance after forming the single-node MicroCloud. So this should demonstrate how you can easily deploy a single-node MicroCloud, how you can launch a workload, how you can extend the cloud without affecting running workload, and how you can then make use of additional features that come automatically with the fact that you have a multi-node MicroCloud cluster. Thank you.